Yo, I think I'm live. Yeah, I seem to be live. That's great stuff. So what we are doing today, we are creating a shader manager. This is wrong. Pretty much wrong. Why do we need a shader manager? Because I want it. It's not necessary, but I think it will result in a cleaner code, and when I write code, I really care about it. I take it extremely personal, and I want to make sure that this code is an accurate reflection of my technical acumen. And that's why it might be a little bit of a stretch, because this works just fine. But I just want to be sure that this is implemented as the God intended, basically. And that's why today we are implementing the shader manager. And yeah, let's get into it. Today I was coding a little bit during the English lesson at my university, and one of the guys said, "Whoa, we are not using AI at all to do this." And I'm like, actually, I'm using a little bit of AI. I'm not a little bit, but I'm not using it to code. I'm using it to mainly like give me some ideas, and then I pretty much pull up some article about it, because I think that's the smarter way to do this. Yeah. Let's type everybody. Hello, everybody. P message. Let's go. Okay. So it's called a simple singleton pattern here. And yeah. I've already pre-coded this type manager thing, like a shader types thing. It will be shader manager. I think it's smarter to do it like that. Yeah, and then we can have the parse shader type function here. And what we are going to be doing is that this enum will have what is x runtime? And we will have a vector that will store the unique pointers, I guess. Unique lock. Holy shit. Although, I mean, I want to symbolize that it's like unique and it's yeah, I think it's okay to make it shader. I don't see why it wouldn't be okay. It's probably not okay though. Like, I just don't know it yet. No, I think it's actually okay to make it like that. And then we have void load shaders, and we'll have void actually more like const shader pointer get shader, and it will be shaded type. Okay, I like it. I don't think it needs to be a unique pointer, like, for honesty. Although if you're returning a pointer to it, no, it needs to be a pointer, because I don't want someone to look the reference to it because it expands. Yeah, it needs to be a unique pointer because of that. I mean, I doubt that the case where it expands and we lose reference will ever happen, but for that case, I think that unique pointer is better, because we won't be giving a reference to an object. I mean, we'll be giving a reference to an object, but via like a proxy, and not just directly an object in the vector, right? So that's a little different. I don't think there's anything special about that one. I do. Well, can this happen? I'm not sure. What happens if I do... Like, this is possible. This might happen. I mean, I won't do this on my own, but I guess that this is something that might happen. yeah, so yeah, it might happen. good shit. So we have some linker errors. This is a linker error. Yeah, I mean, I believe that we want to do this. Yeah, I didn't copy X copy. Yeah, it's. Oh, that's so cool. Look at me. That is pretty decent. Oh, I still need to copy it though. Well. Okay. 2UV color space doesn't exist. Interesting that you say so. Given that there's a shader. Wait a second. Given that this can happen, I think it's pretty interesting. Or maybe we just don't throw an exception? No, we do throw exceptions. Let's figure it out. Oh, because UV is color space and not 2UV color space. Oh yeah. Let's call it a shader type because it's confusing. Shader type. Okay, so we didn't break anything. That's pretty good. You're pretty good. You're pretty good. But we didn't exactly like. Oh yeah, and this is actually. Look at this code. I'll be debugging it for hours. Holy crap. Yeah. I mean, I know how this looks, this big try catch, but for now it will look like that, and try doing anything about that. Yeah, so what now? Well, I believe that now we can do something like that. Shader manager. Instance. Get shader. Shader manager shader type. Canvas. Use. Let's try it. Let's try it out. Let's try it out if it works first time. It is what it is, guys. It is what it is. juicy stuff. Yeah, it's pretty cool. I would say that's pretty cool. And then now we can erase this. Let's go to main and erase this. I think about, no, I can do that. I was thinking for a second about making like global alias, so I don't have to do like shader manager, shader type. If we just did shader types as maybe as like not an internal enum, that it would be just faster. And I'm thinking about this, but I need to think some more. What was that? I'm home alone and what was that noise? What the hell? Oh man, we failed spectacularly. Absolutely crazy. Well, yeah, I mean, do this. You're alive. Okay, that's a minor fix. Nice. That's really cool because it makes it actually scalable. So that's really cool, I think. Nice scalable approach. Just modify this, and you have a new shader ready. That's a really cool approach. I like it. Okay. Okay, what we need to do now is to create an SDF. So yeah, let's make another render target. Let's call it. Oh, there's actually an SDF target right now. So how it will work? We will be binding this SDF render target. We'll bind it, we'll clear it, and then we are going to draw on it. But here we are going to create a different shader actually. It will be an SDF shader. And yeah, let's quickly copy this to the SDF and let's copy this here. Okay, so how the SDF works from what I understand. Why don't you have a right? Thank you. So how it works from what I understand is that when we look at the app right now, and we press here, for example, and here and here. So when we press right now, the terrain that has been painted this orange color, this terrain reflects the positions that are the closest to where we pressed, because this point here, basically, this point here tells you, okay, that there is some shadow caster, basically some object that blocks light, right? And it propagates its position throughout the texture, right? So by comparing the UVs of each pixel with the seed, basically the color of the pixel, and calculating the distance, I believe we'll get the signed distance texture. I don't know if that's how you do it. I've never done it before. I've never read about it, but from my intuition, that's what you should do. And so yeah, that sounds like a really easy thing to do. So yeah, let's just try and do it. Let's test it out. Okay, so we need to sample this texture. So we have some UVs. So let's call it vector 2 seed texture. Let's call it GFA texture here because it's more accurate. GFA texture, and let's use UVs. We need those two coordinates only. And now let's calculate the difference. So seed equals seed minus UV. And then let's calculate distance, which is the product of difference. Float this equals to dot product, right? This is a pretty standard pattern you might encounter in a lot of cases, I feel like. Okay. So maybe before anything, we are just going to render it like that. Back free, this. Okay. So it will be just gray, and I think it's good that it will be gray. Well, now that I think about it, well, let's see what happens. Let's just see what happens. Actually, I had the change of heart here. Since we're using this, let's just use a standard output here. Render target, bind default, clear default, and let's see how it reacts to this change. I'm really curious if we got it right on the first attempt. Copy the shaders, yes, and bank. We didn't. Okay. We didn't because we didn't add it here. SDF. And now it should work. And then we didn't copy it. I'm a goofy as goober, man. Oh, I'm goofy, man. Holy crap. I'm goofy as hell. Yeah. Yeah, so goofy stuff. As a matter of fact, it might not be the best loader that was created. Probably not the best loader on the market. Yeah. Let's revisit it. So I think it will be 5, right? Well, I think actually it's a good time to attach a debugger to this editor. I would love that. Okay, get shader instance SDF. Okay. Maybe tentatively, let's print it out here. Okay. Because it happens here, right? I mean, I think it's quite obvious. Include print. Holy crap, man! What am I doing? Sometimes I have this like weird keyboard fuck-ups, and I wonder if I'm alone in that. Oh, that's interesting. It's not as obvious as I thought. That's incredibly interesting. What's going on? Oh, interesting. Very interesting. Okay. So it must be here then. Let's take a look at the parser. It's called SDF, signed distance field, and this is called what? SDF. Also signed distance field. And then this is value 5, array 4, and we have 5 types. Nobody saw that. Literally nobody saw that. Crap, man. What am I doing? Yeah, easy stuff. That's actually crazy, man. Like, That's pretty funny. So the sign distance field is pretty easy transform, isn't it? I wonder. Yeah, I wonder actually. If we can maybe like scale it up. Like what kind of value it really returns? That's my question here. Because when you look at the Radiance Cascades here, and let's take a look at the layer to render, stage to render at this stage. So it renders it all black, right? Actually, I mean all red, and then it kind of like layers the thingies here. And in my case, let's take a look at it one more time. It how similar is that? I feel like this is more concentrated in the middle. I believe that how they do this, maybe they like maybe they normalize this. Can there be like a normal distance here, the maximum distance, right? So the maximum distance would be probably just a diameter, right? That would be the maximum distance here, the longest diameter basically. The longest is it even exist? Oh, just the diameter, right? The longest diameter. Holy crap! Yeah, the diameter. So, how about to just pass in the coordinates and then normalize this? Because that should be normalized. I mean, shouldn't it? We can denormalize it if you want to. Let's call this uniform float diameter. Wait, I have to actually check. Does this calculate a square or a square or actual distance? Let's quickly ask Gemini about it. Yeah, we live, we love. Oh, the code got a square of distance, so they probably square it too. So yeah, so we should probably. I mean, this is really inefficient, squaring it like that. So yeah, I mean, we can probably just get away with using actual distance function here and call it a day like that. Oops. And let's see like how it transforms it. Maybe this will be a little better. And I still wonder if we should. Is there a copy somewhere in the history? Yeah. If we should still normalize it. I never read about it, so maybe yes, maybe no. Oh, no, yeah, now it's brilliant. It just doesn't fucking work. Yeah, wait a second. We need to build it one more time, I think. Let's build it, and because we have this printout, so I didn't see the error message. And I wonder what it spits out on me. Oh, so I didn't do. Where is it? Oh, how did it happen? Yeah. Got the shaders. Open it. Oh, what the fuck, man? Undefined variable dist. What do you mean undefined variable dist? Oh, it's so cool that I can just... Yeah, so that looks better to me. That looks actually better to me. Although, I still wonder, like... hard to tell. Let's open the render doc. Let's open the render doc and see what it says. Texture viewer, resource inspector, launch application. Let's see what RenderDoc tells us. Launch. And capture. Capture the next specific compatibility profile isn't supported. Yeah, it's just talking about the compat. Damn, RenderDoc is doing God's work here, as you can see. What really happened? I wonder what really happened here. He said about the compatibility mode, right? Well, I mean, it happens, I guess. I didn't really care about it that much. But because this looks really dark, but maybe that's just, I don't know, just by the virtue of it being behind the red. I mean, this is pretty cool, man. This is pretty decent, I would say. Now, what my problem is that I have this fucking tearing effect, and I don't know how to counteract this. Which is a problem. Because on the internet there is not much said about it, so I think I'll have to read the actual paper and kind of like learn from the paper how they deal with it. Because I think I'm doing it correctly. Like I have rewritten the shader for it today, actually, to just be like more locked in on what it's doing. I even like parse it into integers because I really believe that doing some of this in floats is just a mistake. But it didn't even help, like didn't really change the situation. So I really like wonder like what can be the problem here. So they're really hell-bent on using. So in the original source code, they're I think using this. I don't think it matters what we use it. Using floats here would probably reduce, increase the. I mean, using the square root would probably increase the computational time, right? So we don't want to do this. I don't really understand why the tearing is appearing here. There's probably like a macro I can create to copy it, but I don't know how. Yeah, you see those tearing effects? Terrible stuff. How to smooth it out? Basically, how to smooth it out, that's my question. But I don't know. I need to learn more about it. Maybe I'm not cleaning some. Maybe something is. Okay, I have this like theory here. Let's test it out. Maybe it's a matter. I don't know. That doesn't make sense to me. But just let's try. Let's try to erase as many of variables that might have some old code in them. Implicit narrowing from vector to float. Current distance vector 2, and this should be float. Same here. No, it didn't help. Maybe I'm doing it too. Like maybe I need to do this more times. Like more times to do this. Like I'm not sure. Like, this is really confusing to me. I need to basically rewrite the GFA code, maybe the source code, like in the main file is like incorrect or something, because it's really messy. What I do is really messy in the source code, so it might be the case. I really need to like sit down and do this proper, because right now it's a mess. Right now it's a huge mess, and I don't like it. Also, at least this is probably good. But yeah, we have sign distance field. I didn't think a couple days ago that I will know how to do sign distance fields. And now I know, and it's actually really, really easy. That looks so good, actually. Actually believable, like, kind of believe that. And it makes so much sense, too. Oh, you know what we can do? What we can do? Yeah, let's try something, because I wanted to see that dist equal dist smaller than like 0.01, let's say, and then do to see what is the threshold. I want to see what is the threshold here, basically, because maybe the threshold is like much greater than I think. Oh yeah, obviously there is some problem right now. Holy shit. Oh yeah, I mean the threshold seems huge. It seems huge. Let's decrease it tenfold. I mean, increase it, decrease it. I guess it depends on the perspective here. Yeah, god damn it, the threshold is massive, man. Like, this is such high precision here. Like, I wonder if the dot is going to be like huge or no. Oh, why did I rebuild it actually? Why did I rebuild it just now? Makes no sense. I want to copy it. Oh, yeah. So it seems to me like the threshold is quite big here, so it works well. Actually that's what I wanted to do for today. I really need to discover how to get rid of the really terrible smearing, and that will be probably by refactoring the GFA code into like a separate file, probably, to make it clean. And it will be done soon, probably off stream, because I don't know. I'm not calling that one on stream, I think. Okay, so peace out.